The world is racing toward an electric future. But there is a problem. We need copper for everything from wind turbines to electric cars, and demand is expected to jump by 50% by the year 2040. The question is, where do we find it? A groundbreaking new study has revealed that some of Earth's richest copper deposits owe their existence not to active volcanic zones, but to the ghostly aftershocks of an ancient continental collision that happened millions of years ago. The Gangdese belt in southern Tibet contains over 45 million tons of copper spread across massive ore deposits. What puzzled scientists was that these deposits formed between 18 and 13 million years ago, long after the oceanic plate that created them had vanished. Researchers led by Dr. Yongjun Liu from the University of Western Australia solved this mystery by studying rock samples spanning the entire collision cycle. They discovered something remarkable. When the Indian plate collided with Asia, carbonate-rich sediments from the Indian margin were dragged deep underground. At depths of 60 miles and temperatures above 1,600 degrees Fahrenheit, these carbonates reacted with iron-bearing mantle minerals. This chemical reaction oxidized the mantle, creating the perfect conditions for copper to remain dissolved in magma instead of being locked away in early mineral formations. The team used these cutting-edge techniques, analyzing mercury and magnesium isotopes to trace the recycled surface materials. These chemical fingerprints actually proved that sediments from the Indian plate played a crucial role in creating the copper-rich magma. This discovery challenges everything we thought we knew about copper formation. Most exploration focuses on active volcanic arcs, but this research shows that fossil collision zones can continue producing ore forming magmas for millions of years after the original subduction stops. The implications are massive. Regions like the Zagros in Iran or the Lesser Caucasus share similar geological histories and could harbor untapped copper reserves. As Dr. Liu explained, this gives us a second wind for copper-forming magmas and opens up entirely new frontiers for exploration. With copper supply already trailing demand, this breakthrough couldn't come at a better time. It means companies willing to explore high-altitude remote collision zones might unlock deposits that standard models completely overlook. The study, published in Science Advances, shows that ancient plate tectonics still shapes the economics of our clean energy future, one oxidized magma batch at a time. For more on this story, find a link to the article on Earth.com in the description.